Give me 1 second while I swap over to HDMI cable. Swap. There we go. Thank you. Appreciate it, Mike. So, hey everyone, Greg Hulette. So, as Doug says, I'm going to be talking about two of my things that I work on: an open source Periscope lifter and the WCBs, the wireless communication board. So, here's a lifter right here. We're going to go over that first, and then we'll quick agenda of what we're going to talk about. It's kind of right. I've kind of forgot about this when I was doing my slides, so it'll be partially right, partially wrong, but we'll start there anyway. So this is the CAD version of the Periscope there. I didn't design the actual Periscope, the metal piece there, that's an IA parts, but I've used 3D printed ones that I've done before, and it's worked fine. Actually works a little better because it's lighter. So the overview, the main reason why I started this, I wanted an IA lifter. I mean, to me, that are the gold standards of lifters. They're fast, they're metal in my mind is more durable. So I wanted one. The problem is I couldn't find one. I was searching for years on the forum, and as I said, I found it was easier to find a leprechaun riding a unicorn on the 30th of February than it was to find a lifter on the forums or the junkyard that wasn't gone in 5 minutes. I mean, I had notifications set up, and I just couldn't find it. So I'm like, all right, I just need to take this and just design something. Yeah, probably. So I had some design goals for myself when I did this. I wanted to make everything open source for everyone to use. And feedback is welcome. Even in this presentation as I'm talking, if you have questions, I'd rather you ask me now in the middle. I like questions. I like back and forth. So feel free to yell out. So anyone's free to modify the parts. Just don't sell them. That's the caveat. So if you need to modify something to make it work, I know some people have done it. That's awesome. I wanted the 3D printed parts wherever possible because it makes it easier. And when things breaks, it makes it really easy and cheaper. I wanted to maintain the footprint of the IA lifter. So it's going to fit in the same spot that it would on a normal thing. So it could fit in Doug's warp core plate or on just that little pie panel. So you could have other gadgets around it. Use the uppity spinner as my control system. I could have come up with something, but something's already out there better than I could have possibly done. So use that as my control system. I want it to be quick. There's a lot that go up and down, and but I want it to be fast. I'd like the peppiness of it. Full rotation of the Periscope and easy maintenance. So I do a lot of maintenance on my droid. Almost every event, I'm taking things apart and fixing it and doing things. So I wanted everything to be easy to take apart, fix, or put back together. So I used pressed inserts versus screwing directly into the plastic. So it just gives you that little bit of a extra thing. So going to the design. So all the things in green here are things you need to print for it. There's not a ton. The things in the blue are there for helping to assemble it. So you need them, but they're not critical to the operations of it. And the things in that goldish color are optional pieces if you have like the peace sign dome plate. So you would need some of that. If you have the warp core thing, you don't need that, those things there, but you have options of how, no matter what base plate you have some options. The bill of material. So these are the things that you need to actually buy for it. It's a bit much, but I have it. Go back to that. This is linked. So here, this is all in the directions as well. It lists everything you need to buy, the price at the time I was doing it, and then a link to everything, the part numbers. So sometimes some of these go out of spec or out of stock, or I think one of these actually went like end of life. So every once in a while I'll replace that. But any feedback you guys give to me, I'll update this and update the instructions. And then really after that, I just wanted to walk you guys through the CAD of it, how it looks, how it's kind of assembled. I can give you the ins and outs of it a little bit better when I'm showing you through CAD. So I'm going to sit down and we'll bring up the CAD for it. So this is the CAD. See, this is the peace sign. I mean, it's close. I had it. I mean, I just measured it with some tape measure, so it's not super close, but this blue plate down here would just mount to that. with some bolts, and then it's either magnet or held on with these clips right here. These clips definitely make it more secure than just magnets, because I've had it fall off and crack with just magnets. So it's.
So you would recommend doing both if you have the warp core system?
So it depends. If you have the warp core system, you don't need to do either of them. If you have this piece plate, this peace sign plate, as I call it, I would recommend doing either this or drilling and tapping threads in the bottom of these support columns and putting magnets there as well. So you have magnet on magnet instead of just, when I had it, I only had a magnet in this base plate, and then I was using the magnetic connection between this steel upright and the magnet, and it was okay, but not good enough for sharp turns, or so double magnets or this locking ring. I have a quick release one. It's hard to see, but it's this little flap thing. It makes it a little easier to undoing these bolts here, but it's not bad. But it would make it more secure. So the things that are 3D printed here are this top plate, this bottom plate here. This is a front piece. That's a back piece. I mean, I guess we'll go through it one by one. So where is my browser? There it is. So the mounting base, we can hide that for now. Hide that for now. So, and just look at the periscope. So the top plate does curve the inner part of the dome. It doesn't touch it, but it's within a 1/4 inch the top of it. So that's one thing you just have to look at. Make sure this isn't top too much. Why does that browser keep hiding on me? There we go. Let's see. Some things, we'll isolate this for a second and go over the features here. So we have heat pressed inserts in these 4 holes with some M3 screws in there to hold on to this. On the bottom here, the uprights go into these 4 and a bearing goes in here. This is oblong on purpose, so I want that lead screw to be able to go back and forth a little bit, because if you're not printed absolutely 100% perfect, those 3 rails will bind and it makes it tough for it to move. So you want this bearing in here to be kind of loose. So that's done on purpose there. So we'll isolate that. I hit unhide everything. So give me a second. And then we'll go back to here. So the periscope, the uppity sits on the side here with some spacers. I have the ribbon cable hanging right back behind it, and it goes straight down. So it doesn't go out this way. It goes right down here and routes down there. It's kind of hard to do that in CAD. The bottom plate is pretty self-explanatory. There's nothing really to worry about there. I mean, you print it out, you put the heated inserts where it shows it. I have all the heated inserts in here in the model. So if you download this model, which is all on GitHub, you can look at exactly how these all go together. All the screws are in the BOM, so you'll know exactly where to put everything. There's no caveats here. It's pretty straightforward. I'm going to try to talk about the things that are unique. So if I get rid of this, where is that? Sorry, I got a lot of parts in here to. Trying to look for squiggly lines. So we'll get rid of the pipe. And this is the internal rotary mechanism. So I have a ball bearing in here that sits in a little hole, and then a washer sits on top of it. And that kind of captures it in there. And that ball bearing sits on top of a limit switch. So the only tricky part is this ball bearing or this washer is too thick for the ball bearing to sit out. So you have to taper the inside of that on the bottom. So it's not the easiest operation to do, but I did it with 2 pieces of plywood and a countersink bit. So I just drilled the hole and then had the countersink bit go through it, and it was just big enough, and it holds on the outer part of the rim. Because if you try to hold it in pliers or anything, you're just going to bend the washer. So that was a little bit tricky to figure out, but you do have to taper the bottom of this. Yeah.
Instead of using a washer, you 3D print something that's already got that burden in.
Potentially. I don't know about the durability of it, because you have something always pushing up on it. So it could. I could think about that. Yeah. an option. Okay, yeah, I did not know that. All right, so good feedback. I love it. So this is a front plate. So these two hold the pipe on, and it just clamps there. So there's a gap there, and when you tighten them down, that'll get clamped. So let's hide that. This goes in the pipe. We'll come back to that. This is the motor. Don't need that. So one other thing I wanted to mention here is the inside of this. This is not perfectly hemispherical either. The front part is, but this one isn't. This one allows the pipe to tilt left or right for alignment. So I didn't want it, again, with 3D printing, things shift, and if your printer isn't perfect, you might have a periscope that's tilted just the slightest bit and it doesn't. So this back piece is oblong on the bottom. It's circular on the top. At the bottom, you kind of see it. It looks a little funny. I do want it to be able to pivot a little bit, and it just gives you a little bit of alignment process there. You see all these heated inserts that I didn't get to hide. This is the back. This is the main thing that holds this piece here, holds the pipe on to these linear rails. I have linear bushings here. You see, they're plastic right now. Well, nylon or plastic, whatever. I had metal ones, but with the magnets, everything, I didn't want metal to get magnetized and have drag as well. So I switched them to plastic. But the only thing is these threaded screws to hold on to that. With the plastic, if you tighten them too much, it pushes and deforms it, and again, causes drag. So that's really this here is probably the toughest part, to get those screws just tight enough to hold on to those bushings, but loose enough to allow it to move easily. So any kind of drag on that is going to reduce the speed.
Are those nuts inset into the thing?
No, these are grub screws or set screws with nuts on the outside of it to tighten against it. So once you get it just the slightest tight, you tighten those screws against the housing, and then that locks the screw in place. So that's how you're able to keep it really loose but not let it move.
You want to use any kind of Loctite or something so you don't worry about them backing out because of vibration and whatnot?
You could, but with the separate screws, you don't really have that issue. But yeah, it's a possibility. You have screws up here for limit switches that interact to the top and bottom. So you have a limit switch at the bottom, limit switch at the top, just like the eye lifter. And these screws are adjustable, so you can raise and lower to calibrate it however you want it. I have the heated inserts down here. I don't use them anymore. I used to, but you have two bushings in here, so it keeps it kind of perpendicular, so you don't have to worry about that. But I do have the 6 on each side, because you have some up front as well, right in there. And this one's angled so you can get actually into it with a soldering iron and screw. So it's a bit trickier, but yeah, I mean, this is the set screw. It's not very lined right now, but, and then a nut goes there. Yeah, so that goes. The motor mount, I have two options, mounting it on left or right. The left does interfere with the periscope or some potentially thing. I know Doug modified his smoker cell to accept this. The right is nothing. It's under the hollow projector, so really nothing is going to come in and out there. So if you don't have your electronic cell here, you could put it off to the right as well. So you have the option to do either or, and that's your option. So we'll move to the rotary system. Where did that go? So using the same motor for the lifter or for the rotary that the eye periscope does. The motor is it's a bit beefier. I went with a steeper pitch or a higher pitch, shorter pitch, a faster lead screw than the eye lifter one. So I needed a little stronger motor to lift it up and lift it down. So it is the 3070 versus the 25B, I think. So slightly bigger, a different motor for the lifter, but the rotary motor is the same. To connect it to the actual periscope, I've got a 1/4 bolt running through the center of this piece here. And then that has 2 nuts on the bottom of it, tightened against each other so it doesn't slip and doesn't come undone with rotary and twisting everything. I did have to grind those nuts shallower because to full-size quarter 20 nuts are just too thick, and I didn't find a really good shallow one, so I just ground some quarter 20 nuts, 2 of them together, and then just able to make the size of one, but I just half each one. And that goes underneath. I'll show that in a minute. To actually connect them, though, it's just a motor coupler. So I had a quarter 20 to a 6 millimeter coupler, and it just bolts together directly. There's no gearing, there's no nothing. The slip ring here is a tangential one, so I think it's the right word. So we'll get rid of this. Maybe you can see this a little better. And we'll get rid of this because we don't need that anymore. So maybe you can see it. So here's the quarter 20. Here's the nuts that are 2 nuts that are kind of split in half. I've got 2 large ball bearings here to kind of hold the periscope. So this should be tight on the outside of the pipe internal. So this should be a pretty snug fit. I usually have to add a little bit of tape, like 1 layer of electrical tape to get through it, to get that to be a nice snug fit. These 2 heat pressed inserts, they actually hold this plastic piece, because this is actually plastic, to the bottom of the periscope. So this piece all gets mounted there. So I'll have these, where did it go? So this is a printed piece, so this gets mounted to the bottom. We'll get rid of this piece. And this is the slip ring that goes over, so the bolt goes right through it. You have 2 wires on the bottom, or 2 sets of 3 wires on the bottom, and 6 that go up to the top. And this allows you to put the light kit in, and allows you to control the lights. And then that light kit gets put through this hole here, the one that with the hollow tube in it. So it would come up to the bottom and go into that. So we'll hide that. And you can kind of see, this is the mechanical piece, just a bolt right into there, into the motor. This is the limit switch with just a little nub that the ball bearing sits on. This piece here, this is the electronics mount for the rotary kit. So if you order mirrors and the uppity spinner, it gives you an option to order this design or the IA lifter design, because my PCB just kind of is a lot smaller. The IA lifter, the motor is offset a little bit because I have the gears right in the vertical, so I don't have that. My motor is right in the middle, so I just open up the hole wide enough to do either or. But I think when I had the IA lifter kit, the actual PCB, I had to grind out the center hole just the slightest bit to get my motor to fit over. So if you have the IA or the uppity spinner with the IA rotary board, you might just have to grind that out just a tiny bit. But that's all I had to do. I don't think that's going to be an issue for anyone. So I want to talk about back here. This is a nylon screw that attaches in here. I've got a nut under here that this screw screws into, and that's how you're able to capture that lead screw and go up and down. In order to keep that going out and going haywire, let me get rid of this. A lot of hiding. I've got this little tiny piece of plastic that I put right down in that little groove. It's got a flat spot down here, and on this piece, you're gonna tighten it up as much as you can before you put this piece in here, and then you're gonna grind up just a tiny little bit of flat spot here, and then when this gets in, it holds this from spinning and keeps it from spinning a little bit. You can also put a little bit of glue, Loctite or just CA glue in this to help it prevent as well. So the 2 is just going to keep this from backing out, because I've had this back out before, so it's not fun, but that little piece does help it prevent it from backing out. And then I think that's most of it. And the limit switch goes here. From up here, there's a wire that goes down to here. The motor connections are the same as the IA lifter one. One of these 6 is for the motor itself. These shoot here, and then the other one's for the light kit. I think the directions I have explain all that, and I'll show you where the directions can be found. But yeah, all this stuff is up there for you to download and play around with. I did create one additional version of this that's slightly longer. So after a while, these belts kind of wear a little bit, and then this tension becomes a little loose. So every once in a while, I think after the first year and a half I've been playing with this, I printed a slightly longer version of this, and it's like super tight now. So maybe a year down the road after you build this, you may have to reprint this one motor mount, and that gets just held on with some screws from the underneath. And then these are the magnets I was talking about. So you can, for the warp core, you really need to drill a hole in the bottom of this and tap it, and then put a screw through it to hold it on there. So, yeah, this is the Periscope. Anyone have any more questions? I'm happy to take it apart if you guys want to see the internals, like for purpose or thing. I mean, I could, let's see. So I'll have a link for that here in a second, and then I'll show you. But I mean, if I run this, it's quick, right? One of the things I wanted was quick, and I don't know if it's as quick as the IA, but it's close, right? So, and then it rotates, it lights up, and does everything that you'd expect a lifter to do. But I wanted it to be peppy, and this is the best I could do.
Yeah.
Yeah. So here's the resources. And at the end of the presentation, I'll have a QR code that if you need to contact me, all my information's on there and stuff like that. So that's the Periscope lifter. If there's no more questions about that, we will move on to the wireless communication boards. All right. So these boards were designed to allow various microcontrollers to talk to others in a unicast direction, so directly to each other, not just throw it out there to the world and hope you get there. I do have that function coming in the future, but right now the way I wanted to do is at the time I had the stealth system, and I wanted to talk to 12 boards in my thing, and I had no way to really do that. So I decided, let's make it all easier for everyone. So initially I have about like custom boards in mind that I had this functionality built into, but somebody asked me if I could break that out. So I created these boards. So it really just allows any microcontroller or Raspberry Pi or any PC or anything to talk wirelessly directly to another microcontroller. I do that using ESP now. So as you can see, it's a proprietary frequency developed by Espressif, the company that makes ESP32s. It's connectionless, so there's no forming of no handshakes or anything in ahead of time. So it just sends a packet. If it gets there, that's awesome. And if anyone knows anything about network, it's just like UDP. So it tries to send it. If it doesn't, oh well, it just reports that it failed, and that's it. If it gets there, it reports success. And we do track that in the WCB, so you can see that. Huh? It's not even Ethernet or anything. I'm just paralleling it to that, so it's not TCP, not UDP. It just, in my mind, it correlates like UDP because it tries, and that's it. It gets about 200 meters away. That's the documentation. I don't know if I'd trust that 200 meters, especially in a noisy environment. But when we're talking inside a droid, you're never more than 3 or 4 feet away at the absolute most. It takes about 30 to 50 milliseconds to send. So if you really, really want to be particular and you want everything to go off at the exact millisecond, you got to account for that 30 millisecond delay. But in reality, no one's going to notice 30 milliseconds. It does use the same frequencies as Wi-Fi, but I've never seen an issue at a con that I've been at. So it uses a 2.4 gigahertz, but even when my phone can't connect to Wi-Fi or Bluetooth doesn't work, I've never lost a signal. I've never had triggered something and then not one of the boards not work. So it's always worked for me. I've never had an issue, but people are concerned, and later on I'll show you how we could address that. So I do have 2 different versions. Well, I have 3 different versions now. So 2.1 is one that I created myself. It's got an ESP32, a smaller chipset than that. This is a custom board. The other one was 1.0. I started selling these to the club. The idea was this is just a standard LilyGo TTGo 1.4 chip, and you could just buy them if it fails and replace it. And I think, Eric, you've done that, right? You had to replace that, or somebody had to replace that. I know
That
that.
was me.
So that chip failed, so they were just able to go buy, I think it was $8 chip and replace it and get it working. The only problem is there's 107, 108 solder points on that. So every one of these I was soldering 108, and it would take me like 15, 20 minutes to do all of these. And when you've got 50 of them, it adds up a lot. So that's why I switched over to these. I get these manufactured from WCB, and they just come as. I just got to break the little tabs off and a little sanding and then load the code. It's a lot easier. So these are the capabilities. So the top one uses a commercial off-the-shelf ESP30 board, or a 32 board with a custom PCB. You got 5 terminal blocks, 5 serial ports that communicate. I could have up to 9 WCBs all talking to each other if you want. I don't know why you would need that many, but it's capable. So it can communicate individuals as a unicast or broadcast everything. I'm still working on the broadcast piece. I think I'm there, but it's got to be close, and it's bi-directional, so things can talk back and forth. So it's not only just you can go one way, you could also receive, and it doesn't matter. The version 2 is all these pieces are the same, except it doesn't use the commercial off the shelf. It uses a custom board that I designed. But they're capable, they're interoperable. You can talk to all the versions, can talk to all the other versions. So there's no issues. It's just a hardware change.
What's the range?
200 meters, it says. Yeah. So you could have multiple droids talking to each other if you don't want. So, I mean, it doesn't have to be all internal to one droid. If you want to use it, like if I was going to do animatronics C3PO, I'd put one in there as well so they can communicate and like trigger each other.
So we were discussing that. So is there encryption on there? So if I have my droid event and somebody else rolls in and it also has the boards in there, they are encrypted so they can't.
They're not encrypted, but there are things you change in the code to prevent that. I can't turn the encryption on because I use broadcast messages. So if it was just unicast, I could turn the encryption on. But since you're broadcasting it to everyone, it doesn't allow you to have encryption on the same time. But I do have mechanisms, 2 different mechanisms to prevent you from cross-talking with another droid. So, and I'll get to that. So this is a sample network overview. So you see the blue boards are WCBs. So I have them 4 in here. And on this one, is the body. So I have either a Kyber, Shadow, Stealth, Penumbra, or any of your controllers that you use to drive. I have a Arduino, Romadome Home, HCR, all plugged into this WCB. On the dome, or dome plate, I have the Periscope, which is the uppity spinner, a smoke cell, anything you have up there. In the dome itself, I have the Logix, the Filthy HP controller, Arduino, PSI Pro. So all those are connected, and you're able to communicate with any of them individually. So the next slide here, I just have a quick example. So it's hard to see here, but I have just traffic flows. And if you look at the presentation, you see that this here is all red because it's all communicating serial. So I have just a little legend up here. And then purple here is ESP now protocol. So we'll look at this bottom one. This is sending the command :F0158 to the Filthy HP controller. So that turns the front hollow a solid color, I think blue there. So if we look at this command gets sent out to the WCB. It recognizes that the command is :W3:S2. So this WCB1 gets that command. It recognizes the W3. It strips the W3 and sends the rest of the command to WCB3. WCB3 receives that. Now the command starts with :S2. It sees that it's going to send it out :S or serial port 2, and then the rest of the command, it strips out S2 and it sends the rest of the command. So you're really just prepending the command you want to send with the destination. So it's the 2-bit. And that's really all it is. You can chain them together. You could do that. So I've got a little bit here about how the board works, but I mean, it's as simple as if you want to send a command, you add these 6 characters to the front of it. If it's a remote board, if it's a local board, it's only 3 characters. So if you wanted to send, go back here fast. If you wanted to send from this guy up to an Arduino, you don't have to put the colon W3, you just put the colon S1 or colon S3, whatever port it's plugged into. So you just kind of, and if you really wanted to be funny, you could put multiple W3s or W2s and you could just ping pong them. It's just always going to strip the first 3 characters and then forward everything else. So if the next board says sending it out W2 again, it's just going to keep on going and going and going. But it's a good way to test everything's working and communicating if you just kind of ping pong it through the network. So in my mind, there's local commands you do on an ESP32, and then there's commands you do to actually execute the commands you want it to do. So these are like troubleshooting things, configuring things, setting up things. So I have just a hashtag L01. So when I'm dealing with all these boards, I want to know what board I'm on. So just a quick way to tell me the host name of the board. So if I'm on WCB1, it's just going to print out wireless communication board 1 or 2. So I usually plug into 5 or 6 boards at a time with 5 or 6 Arduino IDEs running at a time. So it's helpful just to help me understand what board I'm programming or whatever. 02 restarts ESP32 for any reasons. I just like to have a way to do that. And then my system, I'm able to do that remotely. So if you need to. 05, so I track all the stens and the success and failures of all the ESP now stats. So if you're halfway through the con and you think something's not working, you could issue that command and see how many successes or failures you have actually had. So if you're worried about congestion, you could actually take a look at it and analyze it yourself. I haven't seen any failures. I mean, I turned it on earlier. It does get reset every time you restart it, so you really can't save it for later. You kind of have to look at it while it's running, but it does a good way to do that. And then I have some just debugging things. So you could debug ESP now if you're just worried about that protocol, serial ports. If you're worried about how things are sending and tracking that, you can debug that. The loop, if you're, as I was troubleshooting, I had to debug the loop. So I have a loop there. And then you could just enable all debugging or turn it all off. So you have that option to debug some things. If you want to change the baud rate of your serial ports, you could either do that in a sketch or you could do it here with hashtag S, the port number, and then the baud rate. So I only allow the common baud rates that are like in the Arduino IDE. I just kind of do a quick checksum for that. So you can set that runtime. So if you're trying to troubleshoot if one of your boards, what baud rate they're using, you could do that just fine. It does store it. So even after reloading of the config or the sketch, it stays there. So you can clear it with this command. The ESP now password, you can change that as well. That's one of the mechanisms I use to make sure there's no crosstalk. You can clear that ESP now to go back to the one that's default in the sketch. The quantity of WCBs, I put that in the sketch as well, so you're not trying to send it things that you don't really need to, and it just makes it a little bit more efficient. And again, you can clear that.
Actually, how are you getting that on your laptop? Or is it funny? Like,
I use Arduino IDE and look at all that, but you can use PuTTY to console into it. But I just generally use Arduino IDE personally, just because I like having 6 or 7 of it. And you can do it with PuTTY, but I found with other programs you can't so much. But so this is the syntax I was talking about. You have the colon W, and then the X there represents the serial or the WCB number 1 through 9. You have the colon S, and with the Y represents 1 through 5. And then the actual command, whatever that command is. I only deal with strings at the moment, so I can't do hex values yet or binary or anything like that. So if it's a string, which 99% of the boards we deal with are, you can send a command. And then I just have 2 examples there, but I kind of went over them. The local serial, so this was the second part. If you don't want to send it to a different WCBs, you don't put the same WCB number that you're on. You don't even type that. You just put the colon S and then the target there. And then this is chaining commands. So if you want to send a command to multiple locations all with one command, you could do that just by putting an asterisk in between it. So here you could see that it's a rather long string, but it's broken up between asterisks, and it's really these 3 commands, and it's going to process them one after another. It's all going to put in a queue, and as soon as it goes through, it's going to process all 3 of them. And it doesn't have to be, in this example, it's all one board, but this could be W3, W2, W4. It doesn't matter where it's sending. It could be a local thing. It's just going to send it out wherever it is, going to process it one at a time. Right now, it's a maximum of 10 chain commands, but that could be changed in the sketch if you want more than that. And if you don't want the star, you can change that in the preferences tab as well. I've tested a few of them, but I haven't tested all of them, but I've never had an issue. So that's that. And serial only. So if you don't want to use wireless, you can do serial only. It would just require more cabling, but if you're concerned about it, the functionality doesn't change. The way you implement it might change slightly, but it still works just fine. The way I designed it to just strip off the first 3 characters and then process it, it's just going to do that continuously. So just like if you wanted to ping pong the wireless communication, you could do the same thing with the serial. And I have kind of 2 different ways you could do it. It really wasn't designed for this purpose, but it just works the way it does. So right now, if you have the same board set up, you would connect, say, S5 to S4 and then S5 to S5. And then you could just, by putting a command there, you could just say, to get to this here, this board would put, send it out S5, so it'd be colon S5 and colon S5 and then colon S4. So you'd have to kind of add more prepends to it to get it through, but it still works. You still get the traffic, and then you're guaranteed not to have any congestion or anything like that. So this is one of the options. Like I said, the pros are no concerns about RF congestion. The cons, it does eat up some more serial ports, so you have less for actual microcontrollers. And the middle one there actually eats up 2 because you have to have that one in the middle. So the other option is have a dedicated WCB in the middle acting as a hub and your serial router, essentially, where every board takes their serial 5 and plugs it into this WCB, in this instance 4, and then this one is dedicated just to routing. The commands are the same. You still have to put that extra S in the middle, because if we were looking at this one, that's still F0158 to get to the HP. Now it's S5, S5, S2, F08 instead of just W3, S2. So you're adding in that extra bit of characters in there, but it works just identical to WCB. So this is the preferences. It's a little hard to see on here, but when I go through the demo, I'll bring it up and make it a little better for us. But I just have a preferences tab, and this is all you need to change if you download the sketch and make it work for you if you wanted to update something yourself. But I can go through that a little bit more, where it's a little bit more legible. There are a few libraries you need to install, the software serial. Maybe that'll be a little better. Do need 2 serials, the Adafruit NeoPixel and the software serial. And recently, the ESP board version must be 2.17 or lower. I'm having issues with the 3.0 and higher at the moment, so I haven't had a chance to troubleshoot that. And then I just wanted to give you a quick demo. So up here, I've got 3 ESP30, or 3 of my WCBs, and I've got 2 other microcontrollers. One microcontroller is connected to WCB1, and the other one is right now connected to WCB2. But I can bring up the... So this is WCB1. We'll just make this big, and we'll go over the preferences real quick. So up here, the hardware versions, everyone see this okay? So I have the 3 different versions that I kind of sell. So the latest one's at 2.3, 2.1, and version 1. And it's labeled right on the front of the board, so there's no worrying about what kind it is. It's definitely stated. And then you have the WCB number. So whatever WCB number, you'd comment out and uncomment the one. So if this was WCB 2, you would just comment that one out and uncomment that. And then you just only want one of them at a time, because it would cause an issue if there's multiple. The quantities down here, ESC, the WCB quantities, said you can have this up to 9, but I like to limit it to what you actually have. You can change it later on in via the command line if you wanted to add another one at some point. You're like, oh, I need one more. You could just do that command line with the other ones and then load this one properly with the right version. The ESP now, the password. So right, you just change this to whatever you want, and it's one of the mechanisms to make sure you're not cross-talking. Any ESP now messages, the first thing it does is check for make sure the password is the same, and then it'll process it. So if the password's not the same, it's just going to ignore the message. Got the baud rate for the 5 different serial ports. 1 and 2 are hardware serial, so they could be as high as it allows by the hardware. The other 3 are software serials. and it should be lower than 57,600. Just there, even at 57,600, I've seen a little bit reliability issues. So I try to keep those ones a little lower than 57,600, but it does work at that, but that's the stated maximum for a software serial. And this here, the octets 2 and 3. So ESP now uses MAC addresses to kind of pair with each other. And the MAC address is specified in the setup. So it only talks to MAC addresses that it knows about in the sketch. So it only sends it to this specific MAC address. So you want these two to be unique to your droid as well. Whenever I program these, I have a table for everyone I've ever made, and I mark it off so I know. I just keep on going down the list, and that MAC address needs to be unique as well. So these two right here are just, and it's a hexadecimal value. So it's just like this could be A or up to F. So it could be 0 to 9 and A through F. And that's, you just put that. And this all has to be the identical across all of them. And then this is the maximum queue depth is the chain limit. So if you want more than 10 commands in one chain, you would change this. The delimiter for the chain command, and the command character. So if you didn't want to hit colon, if you wanted it semicolon, instead of colon W2, you want semicolon W2, you can change that as well in the sketches. So what I do is I set one of these up when I'm configuring these boards, and then I'll copy this entire preference tab. I'll just hit Control A, copy, and then I will go to, let's say, WCB2, and I'll paste this in this. I'll just erase everything there. I'll paste this, and then I'll go back and change this to say WC2. And then now it's all you need to change for no matter how many boards you have, because everything else you want to remain the same. You want the same hexadecimal values. You want the same passwords. The only thing that's changing is this WCB number. And that's about it for configuring them itself. Do a quick demo. So right now, like I said, I've got my body servo controller and my body controller. So if I send, nope, I'm going the other way. If I send this command, so the :SS1 is on my local Arduino or my local ESP32 body controller. That's how I would send it out. It's serial port. So you kind of ignore this SS1 because that would be specific to whatever control system you use. But the key is there, I want to send it to W2, S2, and then with the word test at it. And then if I do that, you see on W2, I got this debug message. Well, let me clear this off so it's a little easier for you to see. ESP now message received from W1. Incoming target was W2. That is the, oh man. All right, we'll go back. So I sent the command, said this command to W2. So it went out W1. So if I went here, I'll clear this. And actually, I'll clear this one more time. I send that there. So you see now it went to W1, serial chain command. I think yeah. Yeah. So it was plugged into serial 1 or WCB1. So full chain command received. So the target's there. Command descent forward is S2 test. Something's not quite right. Yeah. But this is what it looks like. I mean, this is receiving on WCB2. So it receives an ESP message. Incoming target is W2. That's his local self. So it knows how to process the command. If it sees it's another one, it'll just ignore it. It came from W1. Incoming command included. So that just says if it has a command. Otherwise, it's how I track the stats, whether it's a stat or an actual command. And this is the command it needs to process, :S2S. The command was accepted into the loop. Command length is 9. Serial command. So it sends :PEST to out serial port 2 and then command process. So it's a way for you to debug exactly how things are working through the system. And if I go here and send like W3, you'll get the same thing. And then here's the W1. So serial, it accepted it on serial. It was input on serial 1, and this is the full command that it received. It went into the test, and then it went through the actual processing of that command by sending it, and then you see a delivery success here. So it's just in my mind, it's a pretty easy way to get commands going everywhere you want. So in the future, I'm working on a thing where I can broadcast the command out everywhere. So if it receives a command on any port, it'll just send it to every WCB and every serial port all at the same time. And every board will process it and send it out all its serial port, except the one it came on. I don't want to send it back to the one it just sent, but yeah. All right.
It's coming back.
Okay.
It's when you're switching, it just, for some reason, you dumps the HDMI signal.
Okay. So that's go back to. So that's a demo. I have all the stuff, all the code, everything on my GitHub. I have a Discord server for any troubleshooting as well. It's the same one. That's Periscope. And then I have, like I said, I have the code there. I got all the instructions on the preferences. All the little screenshots you saw me were right from my GitHub. So you can kind of see it. Any other questions? No. And this is how you can reach me. So that's my QR code. And it kind of just brings up a web page with all that information on it. So if you want to email me or my build log and all that stuff. So on the bottom, it's just got some general build info, but 5 volts. Yeah. The actual serial signal is a 3.3, but everything else is 5. And I've never had any issue talking to Arduinos or anything else. It's just, the terminals are 5 volts. So if you see that the 5 or the volts, it's 5. So, and it accepts 5 volt in because I have an onboard regulator to drop it. Any questions?
Until you put your name up, I didn't realize it was you. I look at your stuff all the time. It's great.
Thanks. All right. Well, then that's my time for the day. Thanks, everyone.
Thank you all for coming.